Okay. So today, I think today will be a little boring because today we'll be going into more theory. Okay, after last time's practical, now there is some. Now today is the time to catch up with some theoretical solution architecture. Okay, so now let us start with topics for installation. About we have done the installation, so let us just understand some installation concepts before we can move forward. Okay, so you have something called as a single SID and multiple SID installations. We'll see that what it is, and the SAP HANA file system layout. Okay, now what is a single SID and a multiple SID installation? Okay, just before we can start with this topic, I just wanted to understand of this all people over here. How many of you are actually working on HANA database?
I'm working.
Your name, please.
Manish.
Manish. Okay, very good. What is your level of work? What kind of like you do on your HANA database? What kind of activities you do?
Hello.
Yes.
Can you please repeat?
No, I meant to say that what kind of activities you do on the HANA database?
Particular on HANA database, like
Mm-hmm.
taking backups and what you can say, starting the DB and
Okay.
restarting the DB or stop the DB.
Okay,
Or
I got.
if uh, certain parameters need to be assigned to that DB part.
Okay, good. Okay, anyone else also have worked on?
Yeah, Muzaffar. Previously, I worked in SAP, but I moved to HANA.
Uh-huh.
Yeah, where I'm working for Hack project.
Okay, so you worked on the SAP Cloud Hack.
Uh, yes, SAP Hack I'm working currently.
Okay, what's your name?
Yeah, myself Anand.
Anand. Yes, Anand and Manish. Anyone else have worked on?
Yes, Muzaffar. I did some R&D in-house server.
Mm-hmm.
Not worked on real time.
Okay.
Most of my work is the ECC and SQL.
Mm-hmm.
But in my new project, so I'm getting HANA, so many HANA machines. So I will be working on
Okay,
this.
good. Very good. Okay, so now let us start with this concept of single SID and multiple SID. What is single SID and multi SID installation? See, normally nowadays you will have seen that you get the VM, you install the HANA database on that VM. Okay, and the installation is done on one-to-one basis. What do you mean by one-to-one basis? Means one database on one VM. Okay, is it clear to everyone? Any doubts on this point?
Yeah,
No.
clear.
Okay, so you get one VM. See, normally nowadays nobody goes on physical servers. Okay, nowadays nobody goes on physical server. Normally people now go with the VM which is like created on your VMware vSphere, maybe something Nutanix and many other HPCI. You have something called as this one HCI, hyper convergence infrastructure, something like that. And then you have your cloud infrastructure. So all the things are now in the virtualized environment. Okay, now so this concept of single SID and multiple SID are no longer in use. Okay, so where was it used? Some years before, what happened when SAP came into picture, it didn't directly came as an installable database. Okay, you were not allowed to install the database. You didn't had any like it was not allowed by the customers to do the installation. Then how was it provided? Okay, it was provided as an appliance. What is an appliance? Means a complete hardware. Okay, if you wanted to go for a HANA implementation, you have to contact the implementation partner, yeah, HANA partner. Okay, SAP had many kind of HANA partner like Fujitsu, Huawei, HP, IBM, Dell. These are the different kind of OEMs or SAP HANA partners. So you have to approach them. You have to give them your requirement. They would go through your requirement. Okay, this is your everything, and based on your requirement, they would do the sizing for you, and they will give you the configuration bomb, bill of material bomb for your appliance that they will be providing you. So what was appliance? Appliance was actually a higher end, high capacity hardware. So your appliance was an high capacity hardware. It used to be anywhere between, say, so for example, starting with 512 GB to like 1 TB memory, 2 TB memory, 4 TB memory. Nowadays you have hardware appliances which can have up to 6 TB of memory. Okay, so in the starting days they started providing HANA as an appliance. Okay, and it used to come pre-installed. Even after you get the appliance, you didn't get the root user ID, password for all that appliance and everything. You cannot directly log into the appliance and do any customization or do any kind of installation and everything. So all the installation, all the configuration was done by your hardware vendor. Yeah, but the vendor which provided you with the appliance. And at that time, virtual machine installation of HANA database on virtual machine was not supported. I'm talking about somewhere in the year 2015, I think. Yeah, somewhere 2015 or 16. So installation of your HANA database on VM was not supported. Actually, exactly for your production environment, it was not supported. Okay, so at that time, people used to install the HANA database on the hardware itself. So when you install the if you have gotten hardware, a physical appliance of 512 GB memory. Okay, so now if you get an appliance so big in capacity, now if you only install one HANA database on it, then it will be a waste of resource. Okay, for example, you have different requirement. You have like development, quality, production. Now the minimum appliance, the appliance which came with the minimum memory requirement was say 512 GB. because there was no appliance below 512 GB. If you want to get an HANA appliance, the starting range was from 512 GB. Now, if you brought one hardware, if you install the development database on it, the 512 GB memory is too much for the installation, too much for the development instance. Okay, so now for development instance, you can say 128 GB, 256 GB is enough. So if you're only using like say 30 or 50% of your appliance resource, the remaining 50 to 70% of the resource is getting wasted. So how to conserve, how to like you utilize this wastage? So what they did, so instead of installing one HANA database on one appliance, what they did, they started installing multiple SID, means multiple instances on the same node. Okay, for example, they brought one hardware of 512 GB, so they install both the development and the quality database inside your one appliance, and the second appliance of 512 GB was used for your production instance. Do you get my point over here?
Can you please repeat
Yes.
once again?
Got it.
Okay, so this is just for your information, for concept, your conceptual. You can also install multiple databases. You can install multiple HANA instance in the same hardware, in the same system. Okay, if you do what we did last time, what you did yesterday was a single SID installation. You have just taken one VM and you have installed one HANA instance on it. That is one-to-one single SID. You can also have multiple SID. You can create a VM with a bigger capacity. Instead of say like 32 GB memory, 32 GB memory, I can create a VM with say 64 GB memory, or maybe like 128 GB memory, and I will create multiple HANA instances. I will install multiple HANA instances inside the same VM. That is called as your multiple SID installation. So this is just the example over here. If you see in this example, this is your hardware box. This is the VM. This is the physical VM or your virtual machine VM. So inside this, you have only installed one instance. You have only installed one instance of HANA database inside one VM. Here, if you see over here, this is your VM. This is your VM or your physical server. Inside here, you have installed two instances, the development and the quality instance. Now, what is happening for the development instance? You have allotted only 30% of the memory, and for the quality instance, you have allotted 70% of the memory. Do you get this point?
Yes, we got it.
Okay. Now this is a single host installation, multi-host installation. Now let us move to your file system hierarchy. Now this is your file system layout. This is the layout for single SID. This is the file system layout for single SID. So what is here? This is your top level directory. Top level directory means this is your file. This is your starting point. In the Linux system, in any Linux system, your starting point is your root directory, slash directory. There is nothing beyond slash. So this is your starting point. This is your starting point, which is called as your slash or root directory. Under the root directory, you have two different this one. So for first, you have the HANA directory. Under slash, you have HANA slash HANA directory, and under slash, you have the slash USR SAP. These are the two directories. Under HANA, you have your HANA data directory, and then you have the HANA log directory, and then you have the HANA shared directory. If you check in our Excel sheet, so you can see the mount points over here. See with the mount points that we have planned. So we have planned for HANA data of 20 GB, HANA log of 10 GB, and HANA shared of 20 GB. These are different mount points that we have planned. We have also added one more mount point for slash backup for backing up the database. Okay, we have not provisioned any mount point for slash USR SAP. So since we have not provisioned any mount point for slash USR SAP, it will be like a directory on the slash partition. Is it clear? Is everybody like familiar with this concept of mount points on Linux?
Yes, sir.
Okay, okay, so here it is. So in our case, what we have is that in our case we have a slash partition of 30 GB. We have a slash partition of 30 GB. Okay, this is a slash partition. What we have in addition to this, we have created a data partition. We have created a data partition for 20 GB. Then we have created a log partition for say 10 GB. Then we have created an SID partition for 20 GB. Now these are all the different mount points. So the HANA data is for 20 GB. Now whatever data is been written will go into this 20 GB. It will go inside that 20 GB. It will not go inside your okay, whatever data is been written in this slash data, it will occupy the space in your 20 GB. It will not occupy the space in your 30 GB. Since you have created a partition and you have mounted the slash HANA data directly on that partition, all the data will go in that mount point or in that partition. Even if this partition gets full, even if this partition gets 100% full, you will start getting error. It will not start occupying the space, free space in your slash directory, root directory. Okay, so these are the different mount points that we have created slash 2020. But if you see for HANA data, we have not created any mount point. So whatever space, whatever files you copy in slash USR, it will occupy the space in your slash slash directory, root directory. So whatever files are copied in slash USR SAP, it will occupy space in your slash root directory. Yes, am I clear on this?
Yes.
Okay, so now here if you see, this is our system. If you see in our system, if you go to the top level slash directory, this is my slash directory. Okay, if I check, these are all the directories inside my slash directory. Okay, these are all the directories inside my slash directory. Okay, if you see here, you can also find your USR directory. This is my USR directory. Under USR directory, you will find the USR SAP directory. So this is the directory which I was talking about. And also you have your HANA directory. Can you see? You have HANA directory. Inside HANA directory, you have the data directory, the log directory, and the shared directory. So these are the three directory, and these are the three different mount points. If you want to see the mount points, you can check df-h command. In the df-f, you can see that your slash HANA, this is the logical volume that you have created in the LVM, which is mounted on your slash backup directory. The HANA data, it is mounted on your slash HANA slash data. The HANA log, it is mounted on your slash HANA slash log, and the HANA shared is mounted on your slash HANA slash shared directory. Is it clear till now?
Yes. It's clear.
Yes.
Okay, so now under the HANA directory, you have a directory called by the name of SID. Under each of this directory, you have the directory by the name of SID. Okay, in the data also you have a directory by the name of SID. Under log also you have a directory by the name of SID. Under shared also you have the same directory by the name of SID. Under the data, under SID you have a directory by starting with MNT. Under this you have a directory starting with HDB, and under that you have the directory for your data volume. So if you go into your slash HANA directory, okay, so ls minus capital R slash HANA data, just HANA data. So you can see over here, this is your slash HANA data directory. Under the slash HANA data directory, you have the SID directory. Under the slash HANA data SID directory, you have the MNT directory. Under HANA data MNT directory, you have these different directories. So these directories are for your data volume. So these directories are for the different services. Okay, now Okay, so these are your different services. Can you see the compile server, index server, name server, preprocessor, web dispatcher, access engine? So these are your different services. So you have a data file for the critical ones. So these are the directives which contain the data files for your critical services. So this is this one HDB001. This is the data file for your system name server. So here it is. If you see over here, this is the file for your name server. So this directory is for your name server. Okay, am I clear on this? Just for your additional information, let me open SAP HANA Studio. There, I think in the graphical view, it will be more easier for you to identify. Okay. This is a system DB. Okay, now if you check here in the data volume, you can go on this one, more information. Okay, so here you can see your data about different services. Can you see this is for MNT001? Just expand this. So this is for your name server. Can you see the service name over here? Name server. In this service column, if you see the service column, you can see the service to which this data file belong. This is the path of the data file /HANA/data SID MNT HDB0001. So the first one, the first directory over here, this is for your system DB's name server. Okay, if you see on the second one, this also belongs to your name server. Okay, it has two data files over in the name server. If you see the third one, okay, sorry, the same, it both contains the same directory. So there is no different directory, both are the same directory, HDB00001. I think, okay, this is for the data. The first one is for the data file and the second one is for the log file. So this contains all the log file for your system DB. Okay, /HANA log SID MNT00001 HDB00001. This is for your log file for your name server service of your system DB, and this is the data file for your name server. This is the data file, data volume underscore 0000. If I open now, if I open for the tenant database. Now, what is the system DB? What is the tenant DB? We'll cover that. Okay, now if you go for the more information of your tenant database, so now if you click on this one, now you can see these are the files. Okay, for these two service you have the data file. Okay, inside the same location, HANA data SID MNT00001. So for the index server, what is the name of your this directory? HDB00002. Okay, and then 00003. This is one, and this is for your access engine. Can you see? Okay, so this one is for the name server of your system DB. This one is for the index server of your tenant DB, and this is for the access engine of your tenant DB. These are the three data files that you have. If you install the application server, S/4HANA application server, then you will have more data files. Not much more, but maybe I think 2 or more directories you might be having. Okay, one for the doc store and something for that. So is it clear till now? Yes, everyone.
Yes. But
Okay,
LS
so you
minus
can,
R stands for?
yes, LS minus, see here where it is, here it is. LS minus L. L is for long list. If I only give ls command, it will just show me in the it will not give the long format. So ls minus l is for long format. So ls minus l long format. Then ls minus lh, h will give you your see, if you see over here, let me run this ls minus l capital R. Capital R is for recursive. It will give you recursively. It will show you all the files recursively. Slash HANA data. So this will show you all the files recursively. Can you see? L is for long format, R is for recursive. Now, if you see the size of the file, can you see the size of the file? These are the size of the file. Are you able to read the size of the file? These sizes are given in KB. So you have to convert them into MBs and GBs. So this is actually these sizes, the file sizes is not in human readable form. So if you want to get a human readable form, you have to add H. H, that is for human readable. L is for long format, H is for human readable, R is for recursive. Now if you give enter, now if you see the size, can you see the size of the file now? 3.4 GB, 3.3 GB and 193 MB. Is it clear with everyone?
Okay.
Are we through with the file system layout? How is the file system layout? Slash HANA, under slash HANA, you have one for data, log, and shared. Slash HANA data contains all your data volumes, Slash HANA log contains all your log segments. Then third comes your slash HANA shared. Shared contains all the software file for your HANA data. Okay, all the installation, all the software binaries, configuration file, scripts, everything is contained under slash HANA shared directory. Okay, so and inside the data you have three different. So the first one is for your system DB's name server, the HDB 002 and then the 003. This is for the index server of your tenant database, and the last one is for the access engine of your tenant database. So these are the different file system. Then you have SID, again the log. So this is just the log one. You will have under the HDB naming convention, instead of data volumes, you will be having the log segments. The last one is your SID. SID contains your all the installation files. Okay, the HDLCM directory, the instance directory, the profiles, global, exe, everything. It contains all the binaries related to your HANA database, to start your HANA database, to stop your HANA database, and for everything, backing up, for all this. It is all contained in your slash HANA shared directory. USR SAP contains your host control. What is the host control? Host control is your host agent. The host agent directory, it contains your host agent or your SMD. SMD is solution manager diagnostic agent. Okay, but we are not going to install the SMD. So in case if you're going to install, it will be installed under USR SAP. Okay, am I clear with this file system layout? Okay, the next one is for multiple. This is for single SID, this is for multiple SID. Everything is same, nothing changes. The only thing over here is that when you do a multiple SID installation, see here is your root directory, here is your slash directory, the top level directory, then you have the HANA directory. Under HANA directory, you have the data directory, and under the data, along with data, you have the log and the shared directory. What is the change over here? Only instead of one SID, you have two SIDs over here. So if you go for a multi-SID installation in your slash HANA data directory, instead of having one SID, if you see in our system right now, we are having only one SID. See, we are only having only one SID, slash HANA data and H4D. This is only a single SID installation. So, but if you have a multiple SID, instead of one, you will have two SID. Same goes for your log also. Instead of one SID, you will have two SIDs. Same goes for USR also. Instead of one SID, you will have multiple SIDs. It is not two. You can have more than one. You can have 2, 3, 4, depending on your number of installations. Is this clear?
Yes. Multi-SID and multi-tenant are same or different?
No, this is different. That is different. We are not entered into the multi-tenant yet.
Okay.
Okay, that is related to your database architecture. Here we are just going through the installation file system layout, how your data files and log files are all install this software is located in your file system. Okay.
Yeah. Okay. Okay.
Muzaffar, I have one doubt.
Yes.
You said that in system DB there is a one name server, and name server and access engine will be there in the tenant DB.
Yes.
So in system DB will not be there name server and access engine.
We'll come to that point in the afterward.
Okay.
But for your information, see, the most important service of your HANA database is the index server.
Okay.
Okay, every tenant database will have its own index server service.
Okay.
Okay, every database will have its own index server service. Got it?
Yeah, got it.
But in your system database, the index server service is integrated or combined with the name server. So that is why in the system DB you will find the name server service. You will not find the index server service for your system DB. It doesn't mean that your system DB doesn't have the index server. So the index server function, the index server service is integrated with your name server. Here it is. If you see the services over here.
Yeah.
Okay, so here if you see, this is your name server. Can you see? This is your name server.
Yes. Yes.
This is the name server for your system DB.
Okay.
Okay, and if you mark this one, can you see -H4D?
Yeah.
-H4D. These are the two services for your tenant DB.
Okay.
These are specific to your tenant database. If you have multiple tenant database, for example, if you have more than one tenant database, if you have 2 tenant, 3 tenant, 4 tenant, so these two service will repeat for the number of tenant database that you have in your system. Okay, the rest of the services will be single. The compile server, the index, the compile server, and the name server, the HD preprocessor, dispatcher. This will be single only because they belong to your system DB.
Okay.
Okay, you will have only one system DB in your database.
Okay.
Okay.
Yes.
Now coming to this point of your. Okay, so we have done the single SID and the multiple SID. Now let us move sizing. So just for your information, what is sizing? I think it's better if we take this topic after we cover the important part. I think this also topic, I think we should have covered it after the architecture. First thing I think that we need to cover is the architecture. Let me put it after the architecture, these all points. So installation, sizing, everything will go after the installation. Okay, we will take a 10 minutes break. We'll meet after 10 minutes. Is it okay with everyone?
Yeah, it's okay. No problem.
Okay, thank you. So let us now start up with the architecture topic, HANA architecture. What are we going to discuss in this topic? The database, save point and commit, in-memory database, row versus column store, HANA processes, HANA start sequence. Okay, let's start. Yes. So is my screen visible? Everybody can see?
Yes.
Yes.
Okay, so now let us see, everybody, you all have been saying that you have been working on a database. Okay, so but was it is it under your knowledge that there are two parts of your database? The database that you have been, any database software that you have been using, so it has two parts. It is divided into two parts. Okay, for example, your database management system, the first part of your database system is the database instance. The instance part. What is an instance? See, your instance is that part. Okay, the first is your instance and the second is your database. Your instance is the part which resides in your memory. Okay, the database instance, it is there in your memory. Okay, and it is the logical, or it can say it is the volatile part. What do you mean by logical and volatile? See, memory, you know that memory is an volatile device. If you switch off the power, if you disconnect the power source to the memory, all the data which is stored in the memory will be lost. All data which is stored in the memory will be lost. So memory is a volatile device. So your database instance is also volatile because it resides in your memory. Now what happens in your memory? Now when you start your database, when you start up your system, when you power on your hardware, or when you start up your power on your VM, okay, after that you log in into your operating system, and then you log in with your SID ADM, and then what you do, you give the start command for your database. When you give the start command for your database, what it does, it goes in your hard disk, it reads all the binaries, the software part, all the binaries which are there in the system, all the binaries and all the scripts, all the configuration file, it reads everything, and then it loads them into the memory. Okay, what is there in the memory? The memory is divided into two parts, the processes and the memory structure. What is the processes? For example, your name server, index server, compile server, access engine. These are all your different processes which is loaded in the memory. When you, as soon as you start the database, all these processes from your database, from your hard disk, is loaded into the memory. And when it is loaded into the memory, along with the processes, memory structures are created. What are memory structures? That is, inside your memory structure, tables are loaded. You have buffers. It creates a buffer structure in your memory. It creates a caches in your memory. Okay, these are temporary files. These are caches are for storing temporary files. Buffers are also for storing temporary files. Then it loads tables into your memory structure. So this is the thing which are done when you start your database. So when you start your database, all the information from your hard disk is loaded into the memory, and this loading of the information in the memory is called as starting of the instance. So the database instance is only active in your memory. Is this part clear with everyone? Yes.
What is caches?
Yes, what is it?
Caches.
Your voice is not clear. Is it for me or everyone?
Yeah, it is caches. Just he has the memory structure. There is the third one,
Caches,
caches.
caches.
Yeah,
See,
caches.
caches
Yes.
are like a small temporary space. Okay, now for
Okay.
example, how can I give you an example for this? For example, in your hard disk. Okay, now when you start up your computer, your operating system is loaded.
Okay.
Okay, now what happens now, as and when you start different kind of programs, for example, you use your browser most often. Okay, every time you use the browser, so what happens, this information of your program, it is loaded in your cache memory. Cache memory is the fastest memory which is available to your system. So this program is loaded in the programs which are more frequently used. Okay, these are stored in your cache memory. So the next time when you again want to load that program, it will not go into your hard disk and it will bring that program from the hard disk, but instead it will go to the cache memory or your buffers, and it will bring it from there.
Okay. Got
Okay,
it.
so these are like temporary memory spaces, temporary storage space which is used for like a quicker execution of your programs. Okay, for example, if you when you start up your system, for example, when you start your PC, and immediately if you start, for example, your Excel program, so you will find that it will take some time to open the program. Maybe I think 2 seconds, 4 or 5 seconds, 10 seconds to open the Excel sheet. Now you close that program, you close the Excel sheet, and again you open the same program sheet. Now you will find that the second time it opened very quickly.
Okay.
Okay, so
Yeah.
what happened was that it saved that information in its cache memory. The same also happens for your browsers also. Okay, when you load the browser, it is first loaded into your cache memory. Okay, so next time when you again want to call that link or program, it will first check into its cache memory whether this URL, whether this web page is there in this cache memory. If it is there in the cache memory, it will directly load from the cache memory. It will not go to the internet and download it from the server. But when it doesn't found that that page in this memory, cache memory, then only it will go to your the server and it will load it from the server, download it from the server. Do you got it?
Got it.
Okay, so here it is. So the two parts. So one part is your instance, the instance or your software part. The software contains your binaries, the configuration files, your scripts and everything which is loaded, which is there stored in your hard disk. Okay, this is a software. When you start your database instance, when you start the database instance, all these programs and binaries from your hard disk is loaded into the memory and executed there. Now it comes into your memory. This becomes your database instance. So this is one part of your database. The second part of your database is your data volumes and log segments. Data volumes and log segment. Data volumes are those files where all your data information data is stored inside your data volume. Log segments are those files where all the the logs of your SQL queries are saved in your log segments. Okay, so the database instance, it resides in your memory, in your system's memory. Database instance resides in your system memory. Okay, and it is the logical volatile part. Then comes your database. Your database resides inside your hard disk, and it is the physical. You can see the database if you go inside the hard disk. Okay, you can see your data file. You can open the data file, you can check your data file, but the database instance which is there in the memory, you cannot check your programs which is there in the memory. So this is the physical part, and it is non-volatile. Non-volatile means even after you shut down the system, the hardware, it will not go from your hard disk. It is there in the hard disk. Now, what are the contents of your data volumes and log segments? So your data volumes contains tables, programs, reports, objects, different kind of dictionary objects and everything. Log segments. What does your log segments contains? It contains SQL queries. Whatever SQL queries you fire on the database, it is stored in your log segment. Is this screen slide clear to everyone? Any doubt on this?
No, it's clear.
Yes.
Can you please explain the processes means this one, name server, index server?
We'll come to that point. This is just for understanding your database,
Okay.
the difference between your database instance and your database. Okay, now we will discuss that in the coming topics. Okay, so this slide was only to make you understand what is the database instance, that is the database software, and your database. What are the difference between them? So is that clear with you?
Yeah, it's clear.
Okay, so now let us move to the next slide. Next slide, we have an interesting topic over here, which is your save point and commit. Okay, you have to understand what is a save point and what is a commit. Now let me take an example of a bank. Okay, for example, any bank. Okay, for example, State Bank of India, and then Punjab National Bank, ICICI Bank. Take an example of any bank over here. Now, what happens in a bank? It opens at, for example, 10 o'clock in the morning. The banks opens at 10 o'clock in the morning. As soon as the bank starts, people, all the customers, not people, customers start walking into the bank. Okay, and they do different type of transactions. What kind of transaction means? They go to the counter, they go to the ATM, they deposit money. The deposit of money is one transaction. Then some customers withdraw money. The withdrawing of money is another transaction. So they do different transactions in their account. Okay, so this is a bank premise over here. Now in the background, the bank is connected to its application server, or it's the software, the ERP, the database on which it does all the transactions. Whatever the user comes, if they deposit any amount, the teller will punch that transaction in the system. The system will update the database. The system will send the transaction to the application server. The application server will save the transaction in your database. Is this clear till now? The screen, is it clear to you till now? The bank and the application server with its database and data volumes and log segments. Yes, is it clear till now?
Yes, it's clear.
Yes, yes.
Muzaffar, I have one doubt.
Yes.
So where can we find out the DB instance and DB in real time?
Where can you find?
Where can we find out DB instance and database?
See, here is I've showed you about this. See, this here you can see this is your database. Sorry, cd slash HANA data, and inside your SID, HANA data SID, inside here is a MNT directory. If you go in the MNT directory, these are the different directories over here. Each directory contains your data volume. Each directory here contains your data volume. For example, the HDB001 directory, it contains your this data volume. This is the data volume for your system DB's name server service. Then you have this HDB 00002.00. This it contains this data volume. This data volume is for the your index server, tenant DB's index server service. This one is for the access engine of your tenant DB. Do you get it?
Yes, I got it.
So this is your database. These are the data volumes. If you go inside, if you go into slash HANA log SID, slash HANA log SID, again you'll find the MNT directory. You go into MNT directory. Here you will find different same directories. Can you see? Here you'll find the same directory name set. Then
Yes.
the same names you'll find over here. But here, if you see here, you find all the data volume. If you check for this inside this data directory, you will find all the data volume. But here in the log volume, if you run all this, you'll find all the log segments.
Okay.
Under the log, this is your data volumes and log segments. Okay, this is your database and your data. This one, the binary, it is here in your HANA shared. Okay, this contains all the software, HANA shared SID. This contains all the software over here. Can you see?
Yeah.
This is the software for your instance. This is the software. This is a directory for your instance, the one which you have installed. HDB instance number. This contains your binary. This is the global directory. This is the HDB LCM. This is for the tool, HDB LCM tool with which you install the database. Okay, so these are all your files for your database software. These are your software files, and when you start the database, all these files from there, this directory is loaded into the memory. So if you run this command, it will show you all the processes which are running in your memory. The get process list. Okay, this command will show all the processes which are running in your memory. Okay, so this is your instance.
Okay. Got it. Thank you.
Okay, so now we were talking about the save point and commit. Now, what is a save point and what is a commit? So here is an example. This is your bank on the top, and the bank is connected to its application server. The application server in the background is connected to its database, the HANA instance, and the HANA instance is connected to its data volumes and log segments. Now, what happens when you start the HANA database? When you start the database, so all the tables from your data volumes are loaded in your memory. Is it clear? The tables, when you start your database, since HANA database is an in-memory database, what it does, it loads all the tables from your data volumes inside your instance, inside the memory. Okay. Is it clear?
Yes.
Yes.
Okay, so now when you start your database, the tables from your data volumes is loaded inside your instance, that is inside the buffer, inside your memory structure. Now what happens, for example, one customer, he comes to the teller. Okay, he does one transaction. What is done, he is depositing some money. For example, he is depositing 10,000 rupees in his account. Now when he comes to the teller will open his account. The teller will log in into the SAP GUI software. He will open all the T code which is used for checking his account detail. Now, as and when what happens, after checking his account details, he will make the entries in the field. For example, deposit amount. He will type the amount 10,000, date. He will type the date, account number, all the necessary information. He'll put it in the field, and after that he will click on save. As soon as you click on save, what happens? The tell us from the presentation system, from the front end system, one SQL query will be fired from the system, and it will hit your application server. What query it will be of? It will be of the type insert into. It will insert a new record in the database, in the table, for the account of that account holder who is depositing the amount into his account. Okay, but after this there will be a series of transactions which will occur for that similar one transaction. So it will not directly, it will not be one transaction, it will do multiple reads. It will go, it will read the current account or current balance from the system. Okay, after getting the system, it will verify whether what amount he has, then he will check whether everything is correct or not. It will check for cross verify, then he will save the record in the table again. So it will be a series of transactions. Okay, now as and when the transaction, is hit from your front end system, so it comes to your application server. From the application server, the application server will execute that transaction it will send the transaction to the database. What the database will do, it will apply that query, it will run that query on the data set which is loaded in the memory. Do you get it? The data which is loaded in the memory, it will not update in your hard disk, it will not be updated in the data volume, it will only update the information in your memory structure, in your memory, the tables which is loaded in the memory. Okay, as soon as the application server will pass on the SQL query to the HANA database, the HANA database will execute that query on its data set which is loaded in the memory. Am I clear till now?
Yes, clear.
Okay, so
Yes.
now as and when all the transactions which are executed from your bank, okay, all the transactions, so it will come to your application server. Your application server will execute that on the data set or on the tables which is loaded in the memory. So if you see over here, see there are different transactions which are occurring, which is coming from to your application server. Okay, insert into table, select star from table. So now what is happening over here? Okay, you see this transaction, it came into your it came into your application server. The application server provided the transaction, passed on the transaction to your HANA database. The HANA database executed the transaction on this data set, on this tables which were loaded in the memory. Then the second transaction was for select, though the database will then apply the select transaction in your tables in the memory. Okay, then comes the third transaction, update. Again, it will be executed in your update. It will be executed in the tables in your memory. So it will go on till now. Okay. This is it clear till now? All the transactions which is occurring with the users, with the transaction with the users are doing, maybe on the ATM machine or maybe on the counter, the teller counter. So whatever it is that the transaction are getting hit on your application server. Application server is passing the SQL queries to your HANA database. HANA database is executing those queries in its memory, not in the database, in its memory. Okay. Am I clear till now?
Yes, yes.
Yes.
Now what happens after? Now, for example, from time to time, the SQL developer who has programmed that query, for program or that function, for example, the teller, the counter, the man on the counter, he's using his SAP GUI program, and he's using some T code. For example, he has a T code called as Z deposit. The T code name is Z deposit. When he opens this T code, a program opens, and in that program he can pull all the details of the account holder, and he can like deposit money. Z deposit T code is for depositing money. And for example, there is another T code which is for something like a Z withdraw, that is for withdrawing money. So if the user is coming for depositing money, the counter will open the Z deposit T code, and then he will put the information there and he will save it. So the programmer who has created this screen, the program Z deposit, what he will do, in between every different transaction, he will pass on a commit command. Okay, depending, for example, if he has done any major update in the database, if he has done any major update in the tables, okay, then he will pass a commit command. Now, when a commit command is passed, what happens when a commit command, you can see this red one over here, commit command is passed. When a commit command is passed, all the SQL queries which have been executed in your data set in the memory, these SQL queries are written to the log segments. You see over here, just mark this over here. When a commit is passed on to the application server, when a database instance receives a commit command, all the SQL queries which are there in the memory, there is a buffer. There are different buffers. So there are some buffers for SQL buffer. Those are called as SQL buffer. In the SQL buffer, all the SQL queries are saved for the time being. So what happens when a commit is passed? What the database does? It copies all the SQL queries from the SQL buffer into your log segment and clears the buffer. Okay, it copies everything from there and it clears the buffer in your memory. Okay, now this activity or this event is called as a commit. The commit is when your SQL queries from your memory is written to your hard disk, persistent storage is written to your hard disk in your log segment. That is called as a commit. Yes, everybody clear with the commit? What is a commit?
Yes.
Okay, now next comes here. Now what happens to the database? Now only the SQL queries have been written from your memory into your log segments in your hard disk. What about the data which is there in your memory, the tables? If at this stage, for suppose if your system gets switched off, okay, for any kind of like disaster, okay, for example somebody mistakenly switches off the power supply to the server. Okay, and there is no UPS backup, there is no power backup, and somebody mistakenly switches off the power. The power has been disconnected from the server. All the information from the memory will be lost. Now what happens to the data which has already been written inside your memory? Will it get lost? No, it will not get lost, because see, we have already, because it is the responsibility of the developer to pass commit commands after every major update in the database. So after he has written any major update query, insert query, something like this, he will pass a commit command. So the commit command will save all the queries from your memory into your hard disk in the log segment. Now what happens? There is a regular interval every 5 minutes. After every 5 minutes, what happens? The database will copy all the change information from its memory into the data volumes in the hard disk. Okay, this occurs every 5 minutes. It is default for HANA database. Every 5 minutes it occurs. What is it called? It is called as a save point. This same phenomena, this same event or activity in Oracle is called as a checkpoint. Same activity in Oracle is called as a checkpoint. In HANA database, it is called as a save point. Every 5 minutes, a save point is triggered. It is triggered by the system by default. Every 5 minutes, a save point is triggered. What it does, it takes all the data which is changed in the memory, and it writes into your hard disk, in your data segment, in your data volume. Is that clear?
Yeah, Muzaffar, one doubt.
Yes.
So data from that instance first going to log and then to data, from log to data volume, log segment to data volume.
Yes. No, not from log segment to data volume. See, can you come again? Can you again brief what is the question?
Like in here in that presentation you are showing from data instance to save point.
Yes.
But I'm thinking it should first go to like log, then to data.
No, why will it go to the log? See, log comes in your memory. It is already applied in the memory to the data set which is there.
All the transaction first written to log, and then from
So
log
it is
to
written.
data.
It is written to the log buffer, not to the log segment.
Okay.
Log buffer in your memory. See, you every transaction you have to take it to the log segment, which is there in the hard disk. It will become very slow. Okay, that is called because if you try to do it synchronously, your database will be very slow, because see there might be very big transactions which are written every second, every milliseconds. If every transaction is first recorded in your hard disk and after written on the hard disk, then it is applied into your memory or into your database, it will become slow. Okay, so when you say that the log, so when a transaction, when from your from the SAP GUI, when any transaction is triggered, what it does, it first write that SQL query inside the log buffer, of your instance, which is there in your memory. From the log buffer, it is applied into your tables which are loaded in the memory. And from time to time, when a commit is fired, all the information, all the queries in your log buffer is written into your log segment on the hard disk persistent layer.
So that log segment, we are using it further anywhere after
Come again, what for?
when that data is coming to log segment, are
Yes.
we using it further anywhere from log segment?
Yes, we are using it. So I will come to that point. So okay, so now here, did you get this point? What is a commit and a save point?
Yes.
A commit is not periodical. A commit is not triggered by the time. It is not time based. It is triggered by the developer inside the query, inside the program. Inside the program, for example, a developer is putting some major insert query on the database. So after that query, he will trigger a commit command, so that this as soon as this command goes in the log buffer, it is executed on the memory, a commit should occur and it should write all this information from the log buffer into the log segment. That is called as your commit. Save point is interval based, it is time based. So it occurs every 5 minutes. Every 5 minutes, all the tables, all the changes which is done in the table data set. Okay, this is something in the Oracle, it is called as dirty buffers. Okay, dirty buffer. So after every 5 minutes, it collects all the data which has been written in the memory. It goes and writes into your data volume in your hard disk. That is called as a save point. Is it clear till now? Save point and commit.
Yes.
Now coming to the point, now I asked you a question some time back. Okay, for example, everything is stored in the memory. HANA is an in-memory database. What happens if someone shut down the server, or someone like mistakenly shut down the server, or for example, if there is a power cut, okay, and the UPS didn't took over. The UPS had some problem, it didn't took over on time, and the server got shut down. Now, for example, now whatever information is passed on in your from the bank, for example, let us take from the bank example. Now one customer for example at 11 o'clock, one customer enters into the bank, he goes to the counter and he deposits 50,000 rupees in his account. Okay, at 11 o'clock. Now 11 o'clock, there was a save point which was triggered in the database. The customer, the transaction of this customer was recorded at 11 hours 1 minute. The transaction was recorded as 11 hours 1 minute. Now there 11 hours 2 minutes, 3 minutes, 4 minutes. Now before 11:05, before the next save point could be triggered, what happens? The data with the system suddenly is power down. The system suddenly goes down. So the transaction which the user, okay, the transaction of the user that he has deposited 50,000 in his account, it was punched in by the teller, punched by the this counter. Okay, that transaction went only into the memory. It didn't went into the hard disk, and the database was restarted or shut down. Now what will happen to the transaction? What will happen? What the whether, because see, the transaction didn't went to the hard disk. The next time when you start up the server, it will load all the tables from your hard disk. It will load all the tables from your hard disk, and that information, that transaction will not be there in the records of the hard disk, in the records of the tables. So what about the 50,000? What will the bank employee, the bank people say? Sorry, we are sorry. We did your transaction, but it was not recorded in the database in the server. So your transaction is lost. Please forget your 50,000 rupees. See, this is not practical. This is your, when you're using a database software, when you're using a software application ERP, it has to be 100% foolproof. Okay, it has to be 100% foolproof. Now what happens? See, I told you the example of a commit. Now whenever a commit is triggered, now what happens? The program which the counter is the teller is running on his front end PC. Okay. Now he takes the 50,000 rupees from the customer. He puts all the information in his screen, the date, the name of the customer, the account number, the amount 50,000. Then he clicks on the save button. When he clicks on the save button, one SQL query is generated in the front end system. One SQL query, for example, insert into account table, insert into table account, and this and that, it an insert query is updated that on this and this date an amount has been added, deposited into the account. So when the teller clicks on the save button, an SQL query is generated. Though that query is first sent to the application server. Application server sends it to the database. The database execute that query in your memory, in the memory data set. The query is executed in the tables, in the data which is there in the memory. After, as soon as this query is triggered, the programmer has programmed for a commit command. So after the query is hit the application, the database instance, the commit command is passed to the database, and till till the time the teller, till the time the person who is taking the amount from the account holder, till the time the acknowledgement for the commit command is not received in the front end PC, the transaction will still showing as in process, waiting, updating, something like that. So when the commit command goes to the database, then the commit is triggered. All the information from your data buffer, log buffer, is written to your log segment in the hard disk. Then only the front end PC will receive an acknowledgement that the transaction has been saved. Okay, so your data has been saved in the log segment, not directly in your data, in your tables, because that will be saved after every 5 minutes. Is this point clear till now? Okay, after every deposit or withdrawal, now until and unless the front end PC gets the acknowledgement for the commit, whether the data has been successfully saved inside the hard disk, it will not allow the person or the teller to do another transaction. It will not give you an option. It will just say updating, saving, something like that. Once the front end PC receives the acknowledgement that the data has been written to the log segment, then it will allow it to use the screen or use the second. You can start with the next transaction. It will ask the next person in the line to come and start the transaction. So here till now the data has been successfully stored in your log volume. Okay, it has been updated in the table. It has been updated in the tables in your this one memory, but it has not been written to your data or data side. So here I was giving the example that 11 o'clock a save point triggered. At 11:01 a customer came into the bank and he deposited 50,000 in his account. At 11:04 the system shut down, or the server got reboot, anything, and the server got down. Now all the information in the memory was lost, because memory is volatile. Okay, so now what happens now in HANA database? Now in the next time when you start the database, now next time when you power on the hardware, and you do all the maintenance activity. Okay, some, for example, the cable got damaged, so you replace the cable and then you power on the server. Then the server comes up, you log in into the operating system and goes into your SID ADM. You start the HANA database. When you start the HANA database, what the HANA database will do, it will read its last status. It will see that some queries have not been applied in the data set which was there in the memory at the last time when it went down. So what it will do, it will recover those queries which have not been applied in the data set from the log segment. it will load those SQL queries from the log segment. It will load the database. It will load the tables from the data volume inside the memory, and whatever transaction has not been applied, it will apply that transaction in the data. It will apply those transactions, those pending transactions inside the temporary space in the data set which is loaded in the memory. This is called as recovery. Okay, so sometimes if you abruptly shut down the server, next time when you start the server, it will take a longer time to come up. Why? Because it is trying to recover all the lost transactions which it lost during the last abrupt shutdown. So next time when you bring up the system, it will try to recover all the open transaction, all the open this and all. It will apply it on the in the database, and then only it will allow you to log into the system and see the value. So after it will do that, then after if you log into the system and check the balance, you will find the balance of the user which was done at 11 hours 1 minute. Do you get this point?
Yeah, so it's
Yes.
it's a automatic process each time
Yes,
when we start.
everything is been programmed by the database. Everything is done at the database level.
Okay.
Nothing here is manual. Nothing here is like this. Do you get it?
Yes.
So this is your save point and trigger. Sorry, save point and commit. Now comes your row versus column store. So everybody has come to now everybody knows that okay, your HANA database is a in-memory database, and also your HANA database is like column store. It has column store instead of row store. So it is not like that your HANA database is only column store. Okay, it is not like that. It stores it loads data in the memory in column store as well as row store, depending on the type of the transaction. Do you get my point? Am I clear on this? Okay. Now if you are loading a table, if you are loading data from your tables from your hard disk into your memory for reading, okay, only for reading, in that case it will load those data as a column store. But if you are loading the data in your memory for writing, it will load that data as a row store, because row store is optimized for writing. Okay, if you have a high number of writes on your table, then it will load all the data in row store in the memory. And if you have a high level of read on your system, for example, your system is used only for like running reports. So running reports is only like a more number of read requests rather than write requests. So these type of requests, it will load the data as a column store. What is a column store and what is a row store? Now in the first example, if you see in the first example in the screen, the first example is a example of a row table. The first example, where can you find is it? You can see here it's a table A as a row table. So first example is for your row table. Now what it is doing, it is running this query, select A, C from table A. So there are two columns, column number A and column number C. Now what it is doing, it wants only the data from this two column. It wants the data only from this two column. But since it is a row table, your data will not, it won't load only those two column in the memory. Okay, because the architecture doesn't allow. Even if you need only two columns, for example, in a table you have 50 columns. In a table you have 50 columns. Out of this 50 columns, you need only like say 3 or 4 columns. You need only 3 or 4 columns for doing any calculation, for doing any like say calculation. But since your database is a row store table, it will not load only those two columns. It has to load the whole row. And when it loads the whole row, it means it will load all the 50 columns. It will load all the data from the 50 columns into the memory. So for example, in this example, if you see, there are how many columns over here? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 columns over here. In these 8 columns, you are only trying to load 2 columns into the memory. But since this is a row store, it will also store data of all the non-relevant data in the record. So you can see over it is also recording all the data. It is also recovering data as a non-relevant data also in the memory. So if you see over here, out of the 8 column, only 4 columns are relevant to your query, and the data in the 4 columns are waste. So what is happening? You are only using 50% of the data which was loaded in the memory, and 50% of the data is discarded. So you can see it's a waste of resource. Okay, for example, it's a use table. You will be loading all that table, all the data into that into the memory. For example, that table, those records will be, say example, say like 10 GB of data. So you will be loading all those 10 GB in the memory, and out of the 10 GB, only 50% you will be using. So 55 GB of the 10 GB which is loaded will be wasted. Do you get this point?
Yes.
Now what happens when you do over here? Now second, your type of option is your column table. Okay, this is your column table. Now what happens in a column table? When you run a query in a column table, select A, C from table A. What it will do? It will directly go and read your columns. It will not read the whole record. It will not read the whole record. It will just read the column. So it will load only the information from your column. For example, it will record the data from your column A and then your column C. Only those 2 columns will be loaded inside your memory. Other, for example, there's an example over here. For example, your table has 10 columns, but you need only 3 or 4 columns. So only those 3 or 4 column data will be recorded in your memory, because that is called as a column store. Because your database is optimized, or your database can read the table as a column. It can directly go and read the column. No need for going it through row wise. Okay, so when you load only the specific columns in your memory, then you have more specific or relevant data in the memory. So here you will be loading all the 100%, of data which is loaded in the memory is used, and 0% is discarded. Do you get my point?
Yes.
Any doubt on this? Yes, anybody?
For me, it's clear.
Okay, so I think there is I think this slide is a little confusing. Now just ignore this part. Don't look into this part. If you look into this part over here, so this is your table. Okay, this is your table and this is your record. Okay, this is your column. This is the column. These are the different columns of your table. Column A, column 1, 2, 3, 4, 5. These are the different columns, and these are your records. These are your record. Now what happens in a row store table? This is the database will read the record row by row. The database will read the record row by row. First it will read record 1, record 2, record 3, and while the time it is reading all record, it will load all the information in the record in the memory. Okay, because it is a row store. It is a row store, the database. Okay, now what happens in a HANA database? Now when you run this record in HANA database, it will not read the record, it will read the column. Can you see? It will read the column over here, one column, and this second is C column. It will directly go and read the column A and C. It will not read the whole record. It will only go and read the column. It will read the column A, whatever information, whatever record, whatever data is there in the column A, it will fetch in the memory. Then it will go and it will read the column C. It will fetch all the data which is there in the column C. Do you get this?
Yes.
Okay.
So yeah, this is a major you can say point of your HANA database architecture. Your HANA database is both row store as well as column store. So it can also do a high performance read write also, write request. It can also run a high quality for your read request also. So that is why it is optimized for both of them, row store also and column store also. Okay, now comes your what is an in-memory database? Why did they started with an in-memory database? What is the use of an in-memory database? Now what happened? See earlier what happened? The records were very low in number. As the time expanded, the database started getting very inflated. Okay, many things were recorded in the database. Many were things are now all the information which is there in the database, it has to be made available to your database software which is there in the instance which is there in the memory. Okay, so the instance which is there in the memory, it reads all the data from your hard disk. So now this is an example they're giving the example over here. What is this example over here? See, this is your storage layer. This is your storage layer, the storage disk. All this data, see, you can see all this data is read from your storage disk. All this data from your storage disk are called into your memory. Okay, this is your memory. This is your memory. So this is your memory structure. This is your CPU and the CPU cache memory. Okay, this is not your normal memory, this is your CPU cache memory. So if you see over here, the CPU has a very limited number of cache memory. It has a very limited number. Now you have a you have a huge memory. For example, your system has something say like 256 GB, 512 GB, 1 TB of memory. Okay, but your CPU is still very less. Now for example, everything will reside in your storage disk. All the data is there in the storage disk. Now the problem is there of your IO. Now there is a problem of the IO, the time that is required to load all the data from the hard disk into the memory, that is called as IO, input data from your hard disk into the memory, and output the outward flow of the data from your memory to your hard disk. This is called as IO. So this actually is a little slower. Your memory is faster, CPU is the fastest. CPU is the fastest. Next to the CPU is your memory, which is faster. Third is your hard disk. Your hard disk is relatively very slower. Okay, nowadays you have your SSDs and everything available, which is very fast in speed. But if you compare with your this one magnetic hard disk, then it is very slow. It is something like that. Your CPU is a jet. Jet means your jet aeroplane. Your CPU is a jet aeroplane. Your memory is something like, you can say it's like a Formula One racing car. And your hard disk is something like a bullock cart. So the information which has to be loaded from your hard disk into your memory, these creates bottlenecks. Okay, because this is very slow. Every time the database needs some information, it has to go to the hard disk to load that information. Now previously what happened, previously all the database were not in memory database, so they didn't had huge memory, they didn't had large memory, and all the data were loaded from the memory on runtime. Whenever it was required, it was loaded from the hard disk when requested. Because of this, it was relatively slower. Now what happened with HANA did what is said. Now they HANA is an in-memory database. It means it stocks a huge amount of memory. Okay, it reserves a large amount of memory. And what happens when you start the HANA database, most of the information from your database is loaded in the memory at load time only. At the time of starting the database, most of the information is loaded in your memory. So next time when the database needs some information to update, it doesn't has to go to the hard disk and get that record or get that data from the memory, because most of the data is there itself in your memory. It will directly go, it will update the record which is there in the memory, which is very faster. Since I gave you an example, your memory is like your Formula One racing car. What is the speed of a Formula One racing car? Okay, somewhere like 250 kilometers per second up to like 300 kilometer per second or miles per hour. I'm not clear of this part. So here it is. So it is very faster, 300 kilometer per hour. Okay, 300 kilometer per hour. such a speed, and then you count with your, like for example, your bullock cart, or not your bullock cart, now normal taxi or normal centro car and everything, which might have a maximum speed of say like 80 or 100 kilometers per hour. So you can see that the huge difference between the speed of your memory and your disk, storage disk. So that is the reason in-memory database, all the data from your hard disk is loaded directly into the memory on startup. So the next time when the HANA instance, database instance needs some information, it will directly go and fetch from your memory, which will be very faster. Is it clear with everyone?
Yes.
Okay, so that's good. Let us move forward. Okay, now comes your single container and your multiple container concept. The concept which I think Dinesh had asked about, the single container and multiple container. Uh, yes. So what happens in a single container and a multiple container? If you see the screen over here, if you see in the screen over here, what happens over here? The box on the left hand side of this slide is your single database, is a single container system. Now what happens in a single container? When you install the HANA database, only one database is created. Okay, only one database is created in a single system container. Now this when you this is your storage, this is your storage disk attached to your system. This is your OS, which is on your hardware or your VM, anything physical or virtual. So this is your operating system on your physical or virtual machine. This is your storage which is attached to your VM. This is your instance, this is your DB instance. Now inside this DB instance, you only have one database. Can you see inside your DB instance, you only have one database. That database is connected to your application server. For example, application X. Is this diagram chart clear to everyone? What is a single container system? What is a single? Okay, it means it will only have one database. And normally this was the normal concept up till maybe I think maybe 3 or 4 years before. This was the normal concept even in HANA also. Okay, even in the Oracle database, if you go in the Oracle database, as soon as you install your Oracle database, you create a database. You create a database. So by default, you create only one database. Do you get my point?
Yes.
Okay, now if you come to the multiple container, what happened afterwards? They HANA this for the HANA development, what they did, they splitted the database. Now here, if you see over here, your storage, this is the same. This is your storage layer. This is your operating system or hardware layer. Okay, which contains your VM or your physical machine, or maybe you have a physical machine. On top of the physical machine, you have your hypervisor, your maybe your VMware, vSphere, ESXi and all. You have the hypervisor, and inside the hypervisor you have created a VM, and inside the VM you have your operating system. Now what happens? This is your instance. This is your instance. So in the previous option, for one instance you had one database. One instance, one database. This was the normal concept. One instance, one database. Now what did they came up with that? Now here they had one instance, multiple database. For one instance they have, so here they have multiple database over here. Can you see? You have multiple database for one instance. If you see the example here in our running system, you have started the HANA database. Okay, so we have only one instance running. You have only started one database instance. When you started one database instance, you have seen that you can see two database over here. One is the system database, which contains these are all the daemons for your system database. See, this is the daemon for your system database. This is the daemon for your system database. This one and this one. These are the daemons for your system database. And also, other than it has started a tenant database. It has started a tenant database. Can you see? It has started a tenant database. So now it has multiple database. system database and tenant database. Now from your point of view, you will say, sir, everything looks same to me. What is the difference over here? Can anybody just tell me what is the difference over here? Any idea, any guess? You don't have to be correct. Your answer shouldn't have to be like accurate or right or anything. You can just give a hunch, just give something like what is the difference over here? Single database and multiple database. Yes, anyone?
HDB name server will be different, I think, in multi-tenant database.
No. Okay. See, what you are saying is that that is just this technical, maybe I think. See, first understand the requirement. What is the requirement for having multiple database? Okay, what is the requirement? See, here you had one database. Here you had only one database over here. Okay, here you have multiple. For example, you have three database over here. One system database and two tenant database. So what was the thing which was not getting achieved in this one, in this layer, having one database, and what is the reason of having multiple database?
In multiple container system, we have two different applications.
Okay.
So each application connected with different database. So within single box, within single HANA database, we got multiple tenant database.
Yes. So see that you can see the requirement. What is the requirement over here? To segregate or to create a boundary for your database. Can you get it? This is the boundary for your tenant database. You have created one database. Now all the data for application X will reside only on this database. So you can also trade from your security perspective. In this case, all the data for your application Y will reside on the database for the application Y. It will not get mingle. Okay, it will not get. Now what happens here? In this case over here, for example, you have a additional application over here. For example, you have an application over here and you have an application over here. Now this application, this is your application Y. This is your application Y. Okay, and here you have an application Z. For example, you have an application Z in the single database container. Now you have three applications, and all these applications now they are accessing the same database. Okay. So what happens? All the tables, you might have different table space for different application. For example, in Oracle structure, you might have not. You might have different schema. Okay, for application Y, you might have schema Y. For application X, you will have schema X. For application Z, you will have schema Z. But if you see over here, the users, okay, the users for accessing your application Y will also be created in the same database. The user for your application X will also be created in the same database. Do you get it?
Yeah, I get it. Means
So
we just define the boundary for each database.
All the users are created in the same database. Now, for example, if there is a security bug or not a security bug, for example, some this HANA the database administrator by mistakenly, if he creates a user with full permission in the single database, now he created this user for application Y. Okay, application Y, the application Y user, he creates a user app Y user. Okay, app Y user for accessing all the information for the application Y. But the application Y user, he after some time he comes to know that with this user he can also read the data for application X also. Okay, why? Because he has the permission. He has a common permission. He has an open permission. He is sitting in the same database. Do you get it? It is similar to like having a common bedroom or a different bedroom. So for example, in the single database, you have a common bedroom. Everybody is sleeping in the same room. Okay, so now for example, you have like a waiting room, you have a common waiting room. Now you have gone to the railway station, you are going to some other your hometown, and you are waiting for your train. Now the train is, let's say, like say 4 to 6 hours late. You went into the waiting room. In the waiting room, it's a common waiting room, every people are sitting there. Now you have some valuable items in your bag. Now what can you do? You cannot sleep, or you cannot go anywhere else leaving your bag, because everything is open over there. In the same case, for example, if you have a different, for example, you booked a separate room for yourself. You have booked a separate room for yourself. You will go into your room, you will keep all your you keep all your valuables over there, and you will lock the room, and you can go anywhere else. Can you get it?
Yes, Muzaffar. So these are two TNet database and they are
Yeah.
isolated
Mhm.
from each other. That system database, is it present in single container as well?
No. In the single container, there was no concept of system database or tenant database. It was just one database. Okay, and all the information related to it was stored inside your database itself.
In
Okay,
HANA
where
Studio, when you're showing today, there was like
it is because we have installed a multi-container database, na?
okay. So it means now the new database, it's by default multi-container.
Yes, I'll show you. I have one slide. In that slide, I
Okay.
will show you about that multi-container and single container, the origin and the history. Okay, so here we have understood. So when they distributed, so what they've done, they've distributed the database for security purpose. Okay, so that the database data of different applications don't get mingle with each other. So that if a user of the X application X has a full access to the database, even if he has the full access to the data tenant database X, he cannot get any information from the database Y, tenant database Y, because this user is only restricted to its own database. Not, it will not work in the other database. Even he won't be able to log into that database. Do you get it?
Yes, okay. And is there any limit for creating TNN database?
No, I've not come across this. I'll have to do some check some reading for that, but I am not. Let me check. SAP HANA tenant database limited. Okay, can you see over here? There's a simple chart over here. It is from your sap.com. Okay, if you have 128 GB database, maximum number of tenant database you can create. You can create up to 10 database. Can you see? If you have a 256 GB memory, you can create up to 24 tenant database. If you have 512 GB memory, you can create up to 50. So this is the table over here. So you can refer this table. Okay, can you see over here? This is a table for you creating tenant database. I think it's a very good article. Let me save it into our library. I think HANA 2. Creating databases. Okay, so it is been added in your okay. Is your question answered?
Yes, most of it. Yes, thank you.
Okay, so now coming back to over here, this is so there you understood why was the reason to introduce the concept of multiple container system. Okay, the concept of multiple container system. Also, one is your security purpose. Okay, creating boundaries for your application. data for your creating boundaries for your application data, so that your application data doesn't get involved with other applications data. So one was creating boundary, then second security, then third also for maintenance purpose. Okay, now here in this case you can shut down your tenant database irrespective. For example, if you have 4 tenant database, if you are doing some maintenance activity on tenant database, say for example say Y, you can go and you can shut down the tenant database Y. You can go and you can shut down the tenant database Y, and it will only shut down the tenant database Y. The other database X, Z, and for example S, T, X, Z, other tenant database will not be hampered. Only the database which you have shut down, restarted, only that database will be shut down or restarted. Is it good?
Yes, yes.
And you also have a system database. System database contains all the information, topology information, all the architecture information, how many tenant database it has, what are the files for the tenant database, and what are the historical data, what are the statistical data for all different tenant data. Those information will be stored inside your system database. One more point, important point, is that users, see, in your tenant database, every database has its own user master record. Every database has its own user record. Okay, it means, for example, if I create a user, say like Amitabh Bachchan in one tenant database, that user will be only specific to that tenant database. If you have 3 or 4 other tenant database, that databases will not have the information of this user from, for example, tenant Y. So this user will only be created in that tenant database. So every user is specific to its own database. Do you get this?
Yes.
Yes.
Okay, now let's move forward. So this is the sheet. I think this is the chart. Your question about Dinesh, that do we install a multi-tenant database or not? So here is a single container versus and multiple container. Now up till HANA 1.0 SPS 09. HANA 1.0, this was the previous version, this was the previous edition. The current edition is 2.0. Okay, the current edition is 2.0. This is the previous old edition, HANA 1.0. So in up till means up t equal to, yani up till HANA 1.0 SPS 09, or before that. Before that, there was no concept of multiple database container. There was only one database. You install the HANA database, it will only create one database. Okay, everything was there, everything was loaded or stored inside that single database. So from HANA 1.0 SPS 09, from HANA 1.0 SPS 09. Okay, from HANA 1.0 SPS 09, what SAP did, they introduced introduction of multiple container database. So at this point, from HANA 1.0 SPS 09, they introduced the concept of multiple container database, and the old system was referred as single container. After the introduction of multiple container, the old architecture was started referring as the single database container. Before multiple database, there was no concept of single database or multiple database. Do you get my point?
Yes. Okay.
Okay, so here it is. So it was introduced from HANA 1.0 SPS 09, introduction of multiple container, and the old system was referred as single container. It was referred as single container. Now what happened in your multiple database container? It contained minimum 2 databases. When you install the multiple database container, it contains minimum 2 database, one system DB and one plus tenant DB. So by default, you will get one tenant database, and you can create multiple tenant database in your database. So here it is. So it can have minimum 2 DBs, one system DB and more than one tenant databases. Okay, so and also up till now, up till this concept, up till this version, up till HANA 2.0 SPS 00, up till this version, both the option was supported. single database and multiple database. Both the options were supported, both the architecture was supported. I remember when I used to, when I did the installation for this older version, it gave me an option whether I want to install a single database container or a multiple database container. Okay, it gave me an option to choose whether I want to install single container or multiple container, where up till HANA 2.0 SPS 00, it supported both single and multiple container database for new installation. But after HANA 2.0 SPS 01, they discontinued support for single container database. So after SPS 01, HANA 2.0 SPS 01, now single container database was no longer supported. If you use the installation, if you use the version after SPS 01, and when you do the installation, it will not ask you whether you want to install a single container or a multiple container. It will directly go and install a multiple container database system. Okay, am I clear on this?
Yes, clear.
Yes.
Okay, I think we'll take a break of 10 minutes and we'll continue after that. Is it okay?
Okay.
Yeah. Okay, so see you after 10 minutes. Okay, so we saw the single container and the multiple container database. Now let us see the main components of the SAP HANA system. Okay, now we have seen that in a single container database, there was only one database, but in multiple container database, you have one system database and one or more tenant database. Now, in case of a tenant database here, how is the architecture? Okay, so here if you see over here, this is your total instance. This is your SAP HANA instance. Okay, this is one instance. Inside this instance, you have your system DB. This container is for your system DB. Okay, and this container over here, this container is for your tenant DB. This is a system DB and this is your tenant DB. If you remember, I told you that the most important service that is running for each database is your index server. So this is your index server for your tenant database. In the system database, the index server service is integrated with your name server. Okay, so this is the main component. Your is a name server for system DB and index server for tenant DB. So when you connect, so for example, if you connect with your SAP HANA cockpit, so it connects to your index server or the name server of your respective database. And how does it connect? It connects using SQL queries. It connects using SQL interface, SQL queries. Other than the name server, you have something for the compile server and the pre-processing server. Again, you have this is common for all the database: compile server, pre-processing database. Other than your index server, in your tenant database, you have something which is called as your access engine. Your access engine is something like your front end application, or it's a platform. It's a platform given where you can develop your own front end application inside your HANA database. Okay, so if you can deploy, you can develop your own application, and you can connect to this application using the web based tools or through client applications. These are the two methods, and both of them will we will connecting using our HTTP protocol. Okay, access engine will only be available through your HTTP protocol. Okay, and if you want to access your system using the client application for SQL, so it will be connecting to your index server. If you see on the screen over here, okay, in this screen over here, you can see that Okay, name server. You can see the name. So can you identify them? This is your name server here. The HDB name server. This is the name server from your system DB. This is the name server from your system DB. Then you have this compile server and preprocessor. Here is your preprocessor. Can you see? This is a preprocessor from your system DB. Again, you have the compile server from your system DB. The compile server and the preprocessor. And then here in the index for the tenant database, you can see here is your index server. This is the index server of your tenant database. And again, if you check, this is the access engine of your tenant database. The access engine of your tenant database. So you can identify this is the access engine of your tenant database, and this is the index server of your tenant database. Okay, and if you connect to your system, so it will, if you use HANA cockpit, it will connect to the name server of system DB and index server of your tenant databases. Is the screen clear? Any doubt?
Yes, Muzaffar. Like
Yes.
there's compile server with name server, system DB and tenant DB as well.
Yes, this
How we are
screen is.
identifying-
Yes, tell me.
How we are identifying like which compile server belongs to which system DB or tenant DB?
Actually, as per this screen, it has a separate compile server for system DB and separate for tenant database. Okay, but if you go in the screen over here, you will find that there is only one compile server for the system DB and one preprocessor for the system DB. There is no compile server, separate compile server and preprocessor for the tenant database. Do you get it?
Okay, okay.
So I think this is this diagram is a little confusing. I need to check it more, like what it is trying to. Why is it showing separate compile server and preprocessor for this tenant database? Okay, now let us move to scale up and scale out configuration. What is the scale up configuration and what is the scale out configuration? See, as the name suggests, scale up. Scale up. Up means what? Above. So scale means if you want to upgrade, if you want to expand. Scale means if you want to expand or if you want to extend anything, if you want to grow anything. So this is scale. Up means about up direction, going up. So scale up means you only have the direction of moving above. So here is an example of your system on the left hand side. If you see the example on the left hand side, this is an example of a scaling up HANA system. Now what happens over here? Here you have, this is your repository. Sorry, this is your persistent storage. This is your DB instance. Okay, this is a persistent storage. This is your DB instance. Now you have this HANA. Now what happens in this node? You have assigned 4 processors. You have 4 processors to the HANA node, and you have assigned memory. For example, you have assigned a 256 GB of memory to this system. It can be a physical server, it can be a virtual machine, or in case it is a virtual machine. Okay. Now what happens? You have assigned this to this server. Now, for example, after some time, maybe after 6 months, 1 year, 2 year, now you have started like experiencing performance issues on the system. Okay, for example, the 4 processors and the 256 GB of memory is proving to be insufficient for the load of the system. Okay, your system is proving insufficient performance, the load is getting more. What you will do, you will add more processor and memory to this existing configuration. Okay, for example, in this hardware, what you will going to do, you will add 4 more processor. So your total processor will become 8 processors. You will add 256 GB or more memory, additional memory. So your memory will become 512 GB. So till the time you have reached your maximum limit, you will keep on increasing the resource. You will keep on increasing processor and memory. You will keep on adding processor and memory. Now, for example, there is an upper limit for this system. The upper limit is that this system will not support more than 1 TB of memory. That is the upper limit. Okay, this system, this hardware, this VM cannot support more than 1 TB of memory, and for suppose say like 48 cores processor or 64 core more than 64 cores of processor. So when it hits the upper limit, now what you will do, you cannot grow now horizontally. You cannot grow horizontally, you cannot grow up. So what you will do, you will grow vertically. Instead of adding, instead of adding more CPUs and memories to your existing node, you will start adding more nodes to your existing system. Do you get this? Yes, everyone.
In second option, we are physically adding the more boxes.
You are adding more number of nodes. Can you see over here? Here you have only one node.
Mm-hmm.
Here you have only one node. Here you have so this is your first node. Okay, when it provides when it proves insufficient, what you have done, you have added one more node to your existing node. Then you will keep on adding node till the time you want to increase the capacity of your HANA instance.
Means we are adding more VMs.
You are, yes, you are adding more VMs or more physical servers to your existing setup. Okay, this is called as a multi-node, multi-host environment, multi-host configuration.
Okay.
Okay, so I have not worked on a multi-node configure environment, but I had one student. He was working on an environment where they had 12 number of nodes for one HANA instance. They had 12 nodes. Okay, and he said that it takes around 2 hours. It takes 2 hours to shut down the database and start up the database. 2 hours each. 2 hours to stop it and 2 hours to start it.
So when we start it, so combine all the nodes. It will combine all the nodes to start.
Yes, it will come up on all the nodes. I think we have a screen again here in the next slide coming up.
Okay.
Yes, this is the slide for it. This is for your multi-node environment setting. Can you see? So this is your node 1. This is the primary node. This is your primary node SAP. This is a primary node, and these are your additional nodes. What all the services will be running on the additional nodes. So your primary node, this is your primary node. Okay, their primary node will contain all the services related to your system database. Your system database service will run on the primary host. Okay, and apart